Okay, now we want to introduce template programming in C++. We'll get right into the details of actually creating my first template class to give you an idea of the syntax that you need to do. For those of you who know classes, which is most of you, as before, we created a HPP file which contains the class declaration, definition of the class with its data, and the CPP file contains the bodies of the functions in the class. It's the same as before, except now we're working with generic data types. So we have to have some means of telling the compiler that we're not working with specific data types, but rather with generic types, and that's what we're going to be doing now. So we'll create our very first class. I will give a demo and we'll carry on. So the idea is the genericity we've spoken about, template classes and how to create templates and how to use the templates. So the example we'll be taking in the demo, let me tell you just immediately, is a so-called interval class or a range. So what's a range? It's between lower and upper bound. So lower and upper. And you create a range. So the lower could be double, could be a date, for example. So like a duration of time. It's your vacation from August to September or something. But basically we're going to create an interval class, a range class with its own functions, like create an interval. Is a point to the left of the interval? Is it in the interval? Is it to the right of the interval? We could possibly have nice functions for intersection of intervals. So this part here, you see. So here's the intersection of two intervals. But it's all generic. So the whole point about it is I'm going to be using the interval in different applications, and we see in part 6 we will need intervals for numerical applications in finite difference, for example. So when we use the template, so in most cases your interval will be of doubles, could be dates as well. So we're heading in, we're jumping into templates now by actually going off and creating a class, my own class. In general, later on we'll be using template classes from the STL, the standard template library, and we've got classes for all sorts of interesting data structures, so as arrays and vectors, matrices, for example, we can create, which may be familiar to those of you who work in MATLAB, except the arrays, vectors and matrices are all dependent on the generic data type T. Let me just write it immediately here. So we create the whole idea is we create a class for matrix, for example. Its underlying type is T, and T can be anything, and consumers use it. You use it in your program. Sometimes you'd like to have matrices of doubles, sometimes you would like to have matrices of floats and ints. So there are lots of containers here and we will discuss them in more detail in the section on STL, which is standard template library. Okay, so let's carry on. A template class is a type, really, yeah? So let me draw a 3-level diagram here. Let's take the very simple example. I've got a vector, let me call it VEC for short, and it depends on a data type T. T is generic, it's not a class, it's like a deferred variable, so that's very abstract. If I say to you, create a vector of T, an object of length 4, let's say, so I'm creating a vector here. So it's got 4 elements. Can I generate a real object with numbers in it? No, because T is as yet unspecified. I can only create, this is a type here officially, yeah? Some computer science jargon. This is a type. It's too generic to be able to do anything with it, yeah? But you code it once. Okay, if I go to a deeper level, I can say, well, wait a minute, can you create a vector of doubles? The answer is yes. So here I replace the T, here's my vector class, and I'm saying My handwriting's terrible, but it's very difficult to write in this way. This mouse wasn't meant for writing. Okay, so this guy here is a class, and that's very important for you to know now, in contrast to the, let's say, standard object oriented way of programming. Vector plus double is the class name. So now I can create objects of the class. I can create a vector now of 4 at one level deeper. So let's just take the values just to be easy going. 1, 2, 3, 4. So what have we got here? We've got an object. So it's a 3-level method. So we're not working on classes anymore. We're working with types, and the supplier creates the type, and the users use the. So here, let me show you. I'm just making it clear. Consumer instantiates, as it were, the vector with the double replacing t, and the off you go, and you can get all this functionality for free. Yeah. So the person, or the code which actually represents the body of the code, is the so-called supplier. So somebody makes the vector class generically, and other people use it. Maybe other people would like to have vectors of floats. Okay, so this is a very important distinction. Okay, so we work with generic types. So we're actually playing the role of supplier when you make your own template classes. In other words, you're working with a type T, and you don't know yet what T is going to be. You don't care. Okay, so as I've said as before, you create header files and you create code files, just as in the good old days, except now we have generic data types. So you have to give the compiler a hint that it's actually working with the generic types, and we use the keyword template, and we introduce the keyword template. You have to tell them what the underlying data type is. You can say type. You can say the underlying data type is a class, but we prefer to use type name, so it's a bit more upmarket, and not everything is a class, but everything is a type name. So it doesn't really matter. Each option compiles. Now let's say I was going to create my own array class. I wouldn't necessarily do it, because later on we'll see in STL it's actually part of STL. Okay. So here we've got the class array, and private has got a pointer to a type. This is going to be my trajectory of values, and I got a size. But now the internal data type is not a double or an int, it's a type, and type is what? Generic, because you've told them this is an announcement saying, here I've got a template class coming along, and its underlying data type is called type. It could be anything, and the keyword is type name. So when you start coding the functions for this class, you can use any word type, because the compiler knows it. So very important to know is the template argument becomes part of the class name. Okay, so if we go back to my example originally, you see here the template argument, the instantiated variant in either case is the class name. So vec and double is a class. So, like in the good old days, you remember we made constructors and destructors. Constructors and destructors are exactly the same as before. What do I mean? The constructor and destructor names are the same as the names of the classes in which they are defined. So functions with template classes input-output argument must have the type. So we can see some examples in a moment. Anyway, so here's my first two examples. Let's say I've got my array class. I want to create the default constructor, of course, and I want to have the copy constructor. So the default constructor is a constructor with no input arguments, as we know. and the copy constructor is an object, create an object as a copy of another object of the same type, you see. So the same type is array plus its type. The array here is the function name, so it's got no brackets, none of this stuff here. But the class name is array plus type. That's crucial that you understand it, because array as a class does not exist. It looks it looks like a class here, but in combination only with its type name, and that's very important. Okay, so some remarks. Choose good names for the underlying types. So I mean, just type is a bit generic, but you can choose names like numeric or something which gives an indication or gives a hint on what the type is going to do. So again, I've said when you're working with template classes, the class name is not enough. You have to give the class name plus the type. As I've said here, the real template class name is array plus type together. Now, how are we going to run my source file? So you can imagine I've got here, for example, default constructor and the copy constructor plus many more, and I want to define the functions in a CPP file. That's no problem. For every function, the bad news is for every function you have to tell them it's a template function. It's a template function, and give the corresponding underlying data types. That's the first statement. You can't just put one big scope, one big block saying all the functions in here are templates. You have to do it per function. Now, per function you give the return type, always. So the return type could also be generic. It could be the T itself, or an array of T's or something. Then we give the template class name double colon syntax, a scope resolution operator. So you give the class name, so this would be array bracket open type bracket close double colon and the function name. So the function name remains the same. It's got no template stuff in its name, at least, and all the input arguments which may be templated as well. So let's take an example. Again, the default constructor. First of all, you see that well, I've got two examples here. I've got two functions. You see both functions must always have the template keyword and the corresponding data type in the as first line. Let's see. If we look at the default constructor name is array bracket open bracket close, but it's in the class array type. So you just code it in such a way, and the bodies should be okay. Here's another example showing you about operator overloading. So I've got the assignment operator in my class. Again, the template keyword. The return type is a reference to the current object, of course, as we know, but it's an array of types reference. The operator is the assignment, is the actual function. We use a scope resolution operator before it, and the input argument is the const array. Okay, so that's more or less it. We'll show some examples in a moment. When we're actually using, okay, so with template classes, I'm assuming in HPP form and CPP form, when you're using your template class in the main method, you have to include the file which contains the source code of your templates. In this particular case, it will be array.cpp because that's what the source code is. That's just the way it is. Some people write header files, inline code we've talked about already. In other words, array.hpp only, and both the function declarations and function bodies are given in the HPP file, in which case you would just include array.hpp. But it means that you have to give your source code away, because you cannot give template code in binary format. Okay, so in my main program I create two arrays. One is an int array, integer array. The other one is a double array, each of length one is of length 10, the other one is of length 20. So what I do is array bracket open int bracket close int array 10. So it creates an object which is of length 10, and it's each element is an integer. Similarly for doubles here, so you can actually create, these are two classes. So array plus int together is one class, and array plus double is another class. Okay, I just mentioned about including source files, CPP files. You already know from your C knowledge that if you include a file twice, it won't work. You'll get a compiler error because it's double declaration. In which case, we have to use the preprocessor directives as we have seen with HPP files. So we'll talk about it in a moment. Okay, we've finished a little bit the classes. We now would like to talk about just generic C global functions. So I have as example, it's an STL, but we've written it ourselves just for fun. I got a swap, and I want to swap two values. So I swap. Let me get back to my pen. I swap two references, T1 and T2. So I create a temporary object. I assign it to T1. T1 is now assigned to T2 and T2 to temp. And this actually swaps two objects. Okay, so you can actually run this in a moment. Now, tips for creating templates. Templates use underlying data types, so they should only advertise what they expect of the formal. They should actually advertise the fact that they need something from the formal data type. So, for example, even in the very simple example in the swap, you see here T is a type, but he's implicitly assuming that the type T has an assignment operator. So if it's a user-defined type, it'll be operator overloading. If the assignment operator is either private or does not exist, you will get a compiler error. So there's no free lunch. You have to tell them what you're doing. In general, if you're creating template classes, make template classes ideally smaller than bigger, because you can always make template classes bigger by using inheritance, possibly composition and aggregation. And a very practical tip is when you're actually writing template code, take it step by step. Certainly in the beginning, if you're just learning, otherwise you get frustrated, maybe. So you take each function and test it and go to the next function, because the compiler errors with templates can be very cryptic. Okay, practicality. As I've said just a moment ago, when we see an example, we can create header files and CPP, which are HPP files, and source files, which are CPP files. Some people, some developers actually put everything into HPP. For example, if you look at the Boost libraries, everything is in HPP. The declaration of the class and its body. As a new developer, which you probably are, it's probably easier just to use template classes than creating your own classes, because you may not have the C++ knowledge yet, and or the actual domain knowledge to actually think of an exciting template class to use. Good news is bad news. Most compiler errors are caused by syntax omissions. So you're missing a semicolon or a bracket. Nonetheless, can be very frustrating. The last hint is flag the assumptions made by the template code on the underlying types. So, for example, as I've said here, the underlying type T should have an assignment operator. If I go back to my range class, which I will show you in a moment as well. Where's my ranged class? Okay, here we are. I mentioned about functions which test if a piece of data is in the interval greater than the interval, outside the interval to the right or outside the interval to the left. It means I need some operator for comparing the value I give as an input argument with the lower and upper values of your interval. So there's certain assumptions. There's no free lunch. This is the so-called policy which we talked about. It's the contract. Okay, so let's carry on. So we're sort of finished with the very simple introduction on how to create your own template code. I will actually show it now with the interval or range class I just talked about. It's very much the same as with object-oriented classes. So you create your header file, your code file. Syntax is the same, except there's one extra level here. in the sense that the data types are generic, in other words of type T, which is unspecified yet. And to give the compiler a bit of a chance to do its work, we use the keyword template. And the example we had until now was that the template class had one parameter, but it can have more than one parameter. Okay, so let me go to my demo. So here I've got a range class, so let me open the I've got some stuff, just let me close it. Okay, I've got a range.hpp file. So it's just a general header file. Just let me go through the new stuff. Just a quick check. If there's some syntax here you don't understand, I'm not talking about the template syntax, but const and references, then you should go back to your C++ and review, because I'm assuming you know it. Okay, so I've got a range. My class is called a range. It depends on the underlying type, and it's got a low and it's got a high. So these are the two the boundaries, the upper and lower limit. I've got the usual constructors. I've also my default, my virtual destructor, modifier functions. Here I've got modifier functions to set the low value of my interval, set the high value, get the low value, get the high value. The spread of my interval or a range is the return type is a type. So it'll be a double in a moment if you're working with doubles. It's just high minus low value. And as I've mentioned before, I've got a function called left, for example, with an input parameter which will tell me is the input parameter to the left of my interval or not. Similarly for right, similarly for contains. And I've got an assignment operator as well. Okay, if I now look at the code file, so this should be fairly familiar at this stage. My code file is the range.cpp. So if I look at all my constructors and so on, so here's the first batch. So here's my default constructor. As you see, every line has to be a template class here, you see. The range is my function, and the range type is the range plus its underlying data type and the double colon. And you see here I just define my 0 values left and right, of lower and upper. Here's another one with two input parameters, and I check the possibility that the my input is just switched the wrong way around. So basically I have to assign low and high each time. Here's the copy constructor, of course, plus all the other functions. Just let me go to the function called left. So basically, here's my input argument, my val. If my val is less than low, I return true, otherwise I return false. So what he's saying is here basically is that the input value is to the left of my range. Here's the contains. We'll show you the contain. So here's my type T. In other words, is T situated in my domain? It is situated in my domain if T is greater than or equal to low, and high T is less than or equal to high, or high is greater than or equal to T. And this is logical AND. So that's the basic class. The test function is a very simple example. We have it models let's say matchstick diagrams, which actually shows you closing price, opening price, high and low prices of commodities in the futures market. So I've got some examples. So I've got a closing price is 45.7, opening price is 60. So I create a range object called bearish, which is closing price and opening price. So this is my range. You see, it's a range of doubles. Here is my current price. So I ask the question: is my current price to the left of my range, to the right? Is it contained in the range? And basically, if test is false, test 1, yes, to the left, of course. No, it's false. And test 2 is false, so to the right, so it is contained. And test 3 is equal to true. Yeah, everything's okay. So that's just a very simple example of actually testing your range class. So we created a range with a float. So instead of using doubles, I use floats. So I got 2 floats here, and I create my float range bullish between 90 and 60. So he switches everything around. So if I run my code, he says everything is okay, which is the piece of text here. So this is my text. Okay. So my advice would be to study the range.hpp, study the range.cpp, see how it works, and make some examples. In the next section, we'll be going to actually not necessarily defining my classes in template classes, but using template classes, in particular STL. Okay, quiz. What are the requirements in type T in the function swap? So if you, by which I mean, if you replace T by some data type, your own data type, what conditions should your data type satisfy? Okay, I want now a max function with 3 input arguments. So each argument is of the same type. Something you need to investigate is the following. How do you define default template parameters? What do I mean by default template parameters? Let me go back to my code, why not? Let's say in 99% of all cases I work with double. So I don't want to have to give up double every time. I just say the following. Range R2 or something. Just take a default value. See, it doesn't work because what I'm saying is here, if I don't give any data type here, the default value is double. So the way you do it is the following. I'm sort of giving you the answer. Default values, and will be very important in STL because many of the STL libraries and classes have multiple parameters, and if you have to give every parameter up every time, it will just drive you crazy. So the most common cases are defaulted. In our particular case, the default case will be double. So I just have type equals double. So if I don't give anything up, he just assumes double. So let's see. Let me just save everything. You see about so I just save my range. Okay, overwrite. That's fine. Okay, if I go back to my main program again, you see that the red lining has disappeared. You see? So we can create a range. So range will be R2 will be underlying types double. So if I run my code again, it should work okay. So everything's okay. On the other hand, this syntax is a bit silly. So what happens quite a lot with templates is the following. I do some type defs. Now it's a bit trivial, but later on when you've got multiple data types and default types, it's nice to have a type def. So type def range double range or something, yeah. Double range, right? So this works okay. Let's see if it compiles. So it's a shorthand, the type def notation, which you know. Wow, it works again. So instead of having to write all this stuff here, double range or range with these funny brackets, I do the following. Each is possible. Double range or 3, yeah, and I just make a copy constructor. You see how it works. So double range is a bit more readable, and let me run it and see how it works. Yeah, it works. So okay, I've actually done the type def for you, but I haven't told you what the advantages are because I don't know the advantages. It's up to you to decide what you want, right? What things change and so on. So we're sort of finished with the basic introduction to templates. The next two sections will be fairly substantial because we introduce the standard template library, our own template library containers, and also the algorithms. So my advice would be to play around with the range class and get some practice using templates.